Finally, I want to talk about the automotive market. I've been pretty bullish in the past on self-driving cars, but we're starting to see that market change. We're starting to see things stretch out in time for the self-driving cars. The good news is we're seeing a lot of deployment of the level 2 features. These are things like automatic emergency braking, lane keeping. Most new cars in the US and other advanced economies have these capabilities today. They work with the driver in emergency situations and to help keep them on the straight and narrow. So that's been very popular. Moving up to level 3, we haven't seen a lot of interest there. There's been a few cars that have come out with some level 3 capabilities. They're very expensive. They've been deployed in very small numbers. One of the problems is that level 3 means that the car only drives itself for a certain period of time or a certain situation, and then it has to hand off control back to the driver. So now you have to monitor the driver, make sure they're paying attention, make sure they're ready to take control at the appropriate time. It's a difficult scenario. What people really want is this level 4 end-to-end autonomous operation. That's been what's been difficult to achieve. And so, we were hoping to see level 4 vehicles in production soon. That's not going to happen. We were hoping to see, people be able to go to their car dealer, buy a level 4 car. That's going to take longer to achieve. And then level 5, which is, the car doesn't even have a steering wheel, that it can drive itself under any conditions. People don't know when that's going to happen, if that's going to happen. Certainly, the cars will become more capable over time, but, whether we'll ever reach that, nirvana of level 5 is really unknown at this point. So what we're seeing now is more of a focus on commercial vehicles. So I think that where we'll see level 4 be deployed initially will be in these types of devices. For example, shuttles that operate in an airport or on a fixed route. And so the conditions are very predetermined. Taxis that work within a geofenced area. Within a particular city, a particular area of downtown. Delivery vehicles, which don't carry passengers, so they don't have to have the same safety requirements. Trucks, long-haul trucking, there's been a lot of interest here that would just move a truck from city to city on an interstate highway, and then you would have drivers that would take it into town to actually do the final delivery. So those kinds of models could be very valuable because of the cost of professional drivers today. So any type of technology solution would be very useful and save these companies a lot of money. This is the kind of thing we could start to see within the next few years, maybe even sooner in some limited cases. And then the idea of being able to go and buy a personal vehicle that operates at level 4, that's probably going to take longer to get to just because of working out the liability and insurance issues, the safety issues, and so I think there's just some questions as to how practical that have to be worked out. There's a lot of challenges to get there from a technology standpoint as well. You need some combination of cameras, LiDAR, radar, probably realistically all 3 of those in a vehicle to ensure the best safety capabilities, and that's adding a lot of cost to these vehicles today, which is why the commercial deployments make the most sense in the near term. In addition to the sensors, you need a lot of processing power. You're going to need hundreds of teraops to process all of this video and then decide what the safest path is for the vehicle. it's hard to have to train these systems today. People have, estimating how many millions of miles of training data we need, but it's probably more than we have. And then every time, you change your neural network, you need to retest against, your training data to make sure that everything is okay. So one of the interesting solutions is actually training the vehicle in a simulator, where instead of having it on the road, you just have screens that then pump the information into the vehicle, which then can simulate the decisions that it would make. So that holds a lot of promise in terms of being able to solve some of these challenges. In terms of the commercial products, we've seen NVIDIA and Intel again. The data center champions are doing well in the automotive space as well. Intel acquired Mobileye a few years ago. Mobileye is the leader in that level 1, level 2 ADAS area. NVIDIA has been targeting more the level 4, level 5 autonomous driving area with more powerful processors. The problem is that you can get up to 400 watts if you put all of the compute power that you might need into the vehicle, and that's just not going to fly. So now the drive is to try to reduce that power consumption while still maintaining the processing that you need. We've also seen companies like Tesla designing their own ASICs. So we expect to see more automakers kind of take control, just as we've seen the cloud vendors build ASICs. The automakers may build some of their own hardware as well. So just to wrap up then, I talked about how AI acceleration is evolving from basic architectures like CPUs to more adapted architectures like GPUs and DSPs, and now we're starting to see new architectures that are custom designed to accelerate deep neural networks. So these architectures use MAC arrays to improve performance. They have other specialized hardware, and we're seeing lots of different types of approaches to accelerating AI. It's a very exciting time to be talking about processors because of all of these new capabilities. We're seeing AI acceleration spread from the cloud today into edge devices like phones and IoT, into automotive. So AI is really becoming a key part of processor design for almost any end market. Even where you can do the AI on a CPU or a microcontroller, it makes sense to put that accelerator in there just to save power. And in smartphones, we're seeing AI already emerging as an important differentiator. So that is creating this performance race in smartphones. In automotive, I talked about how we're seeing some delays in the deployment of autonomous driving, but there's still a tremendous amount of work being done and a tremendous amount of market demand for those solutions. And at the end, I think IoT will be the highest volume application just because it's such a big market. And we'll see lots of AI going into those devices, and we'll be hearing a lot about that at this conference. So thank you very much, and I hope to see you over the next 2 days.